In this lecture here, I want to do two examples of some really interesting integrals by substitution, and they're quite interesting, and they involve a step after you might not be able to find out or figure out what the step is the first time, but like after you see me do one example, you'll be like, oh, okay, all right, I get this process now. So let's take a look at this one. All right, let's integrate x times the square root of x plus 5 dx. So it's really weird, right? Like you look at this and you're like, okay, I know the process. I'm going to let you be the inside here, but there's no derivative of the inside of the outside. So it's like, what's going on? Well, let's trust the process and see what happens. Let's let u be equal to the inside. Okay, so x plus 5. That means du is just equal to dx. All right? So watch what happens if you substitute in this next step here, right? So there's nothing right now to substitute in for x. Okay, there's nothing that replaces it. So this then becomes the square root of not x plus 5, but u. And then look, dx is just equal to du. So it's like, shucks, I couldn't replace anything for x. But look, wait a second. Look, u is equal to x plus 5. So what that means then is x is equal to u minus 5. So it's like, yes, now I can substitute in for x and put it in terms of u. So now sub this in. And then watch what happens, okay? So this becomes the integral, not x, but u minus 5. I'm going to write this as u to the 1/2 du. And then it's like, okay, well, how do I integrate this now? Just distribute, watch. So u times u to the 1/2 is u to the 3/2 minus 5u to the 1/2 du. Now look at that. So even though you did this derivative here, or derivative of the inside, you couldn't directly substitute in, just a little algebra and you were able to do it no problem. Okay, so just general power rule this, right? So this is u to the 3/2 plus 1 all over 3/2 plus 1 minus 5 times u to the 1/2 plus 1 all over 1/2 plus 1 plus c. So look, this is just u to the 5/2 all over 5/2 minus 5 u to the 3/2 all over 3/2 plus c. And then look, you bring these up as the flip. So this is 2/5 u. Well, u is x plus 5. So x plus 5 to the 5/2 minus 2 times 5. So this is minus 10/3 u, but u is x plus 5 to the 3/2 plus c. So it did get a little crazy there, but you just have to remember, if you have like something like just an x left over, see if you can use just a little bit of algebra so that you can get x by itself in terms of u and go from there. All right, let's do another one so you can see the process. It is a little crazy. This one's fun. And you have to be very, very meticulous. Like if you notice here, there's a lot of algebra, and you make one mistake, it throws off the whole problem, so you have to be very meticulous. Same with this next one here. All right, so let's integrate. X squared times the square root of 1 minus x dx. All right, again, be very, very, very careful here. Okay, I'm gonna let you be the inside here, all right? Because you have to, that's always the process. So du then is equal to minus dx. So that means I can replace dx, okay? I can replace dx here with minus du. But look, it's like, oh shoot, I have x squared. Well, look, if I add the x over, subtract the u, I can, wherever I see an x, I can replace it by 1 minus u, okay? So look, this now becomes, instead of x squared, this is the integral, of 1 minus u squared, got the little dx down here, sorry, the square root of not 1 minus x, but square root of u. So I'm going to write that as u to the 1/2, and then minus, because I'm going to replace dx, don't forget you have this minus du. Okay. So a lot going on, and believe me, you have to be very, very, very meticulous here. So how are you going to solve this? You're going to FOIL this out. So this ends up becoming 1 minus 2u plus u squared times u to the 1/2, and then you have this minus 1 du. And this is all the integral. All right, so you're going to distribute, okay? Be very, very careful. You're going to distribute not only a negative 1/2, or you're going to distribute not only a negative 1, but u to the 1/2. So I'll distribute u to the 1/2 first, so you can, see all this. So I have this negative 1. I'm still going to have to distribute. This is u to the 1/2 minus 2 u to the 1/2, u to the 3/2, plus 2 1/2 gets me, this would be 4 over 2, so this gets me u to the 5/2 du. And then you need to distribute the negative, okay? So this is why you got to be very careful. So I'm going to put the positive term first. So negative here becomes 2u to the 3/2 minus u to the 1/2 minus u to the 5/2 du. All right, you can just see here it's just straight up the general power rule. Okay, so this integrates as 2u to the 5/2 all over 5/2 minus u to the 3/2 all over 3/2 minus u to the 7/2 all over 7/2 plus c. Well, now just replace it. So the 5/2 comes up as 2/5, so this is 4/5. Now what is u? U is 1 minus x. So 1 minus x to the 5/2 minus 2/3 u. Well, what is u? U is 1 minus x to the 3/2 minus 2/7 u is 1 minus x to the 7/2 plus c. So again, definitely a lot going on, and why you need to be, you can see there's a lot of algebra here, right? And even a small mistake like adding 1/2 plus 1 and doing that incorrectly can throw off the whole problem. So just take your time. As always, be meticulous, and recognize, like, I let u be the inside here. I didn't find its derivative outside, but I can put x in terms of u, and then substitute it in and follow right out.